We have a goal that's never been done before. We want to take the first picture of a black hole.
Okay, we're ready.
Something that struggles with all of its might to be unseen.
4, 3, 2, 1.
Peter, how are you?
I'm good. You?
I'm doing okay. Just finished up a workout, so sorry if I'm running slightly late.
So no problem at all.
How are you? Look at your library in the back. Oh my gosh, where are you?
I'm home.
Wow. Tell me what at least like a quarter of those books are on.
Well, let's see. They're these books up here are about flying. I fly little airplanes, and I've written about flight and
Interesting.
risk and accidents. And then these are French philosophy. These are history, German and Austrian history. This is archaeology. You know,
And how many have you read out of like that whole pile?
I've read most of them. I have to say they're from
Wow.
projects that I've worked on.
Unbelievable. And
And
of
that's
course
the
you have
black
that.
hole.
Yeah, then you have that picture right there, which is
Yeah.
just why we're here. The one picture got you through this kind of a rabbit hole and through all this work that you put in, producing, directing this film. It was all for a picture, huh?
That's it.
Unbelievable. Tell me how you originally got involved with it. I'm really curious to hear how this project came about. Were you fascinated about black holes? That's one of the life's mysteries. It's always been, you know, we talk about like Bigfoot and stuff, but that's like a legible sort of life mystery of the universe. But what intrigued you about this topic, subject matter, to initially to do this deep dive that took a while to go through this journey?
Well, it goes back to a moment about 5, 6 years ago
Mm.
when some colleagues and I decided that we really all were fascinated by black holes, these most mysterious objects in the universe. One of them is a world-renowned mathematician, another a physicist, two astrophysicists, an observer, and I, who often work between physics and philosophy. And we set up an institute for studying black holes
Hmm.
that began in 2016. And I got fascinated by this project of trying to make an image of a black hole. A lot of my work is on images in science. And in the course of that work, I decided, well, I should film along the way. And for the next 5 years, I did that. And also with one of the other colleagues who helped form the collaboration, Andy Strominger, who's was collaborating with Stephen Hawking and another theoretical physicist, Malcolm Perry, and a young student, Sasha Heiko, incredibly gifted student, and she joined that team. So I began to film, and I just would film each time we would get together at an important milestone along the way. I filmed on the top of mountains where the observing was taking place. I filmed in laboratories and, you know, with the supercomputer and at meetings where we were working on this. And it, as you said, it took a long time. I mean, with no guarantee these projects were going to come to successful
Yeah, how do you
conclusion.
know if you're going to get something when you're filming this all? You don't know if this is going to be the end result, right? No one knows technically because we go along the journey for this.
It was a total miracle. I mean,
Yeah.
you know, that not only did they work, but they worked on the time scale of the period that I had, the 3 or 4 years I had to actually make this film. And I'm not a fast filmmaker, but
Clearly.
but I
It's a
but
good thing.
I wanted this film not to be a retrospective where people look back and said, oh yeah, you know, back in 2016 we did this and then we did that. I wanted to see things unfold. I wanted to capture the experience of working on this planet covering project to make an image of a black hole, and on this incredibly challenging theoretical venture with Stephen Hawking to actually see what it looks like to be working at the very boundary, the frontier of theoretical understanding.
So you were basically right on the side of behind the camera the whole time we're watching. You're the only one that doesn't appear technically in these meetings, but you're there technically, which we don't see you on film and on camera most of the time.
That's it. I mean, often sometimes I had a professional cameraman, and some of the scenes I filmed myself. I decided in the end not to be a kind of narrator presenter, but rather to let the events unfold. I didn't want it to seem like a typical pedagogical film. I wanted it to really bring the audience into the rooms where these things were happening.
And the people themselves tell the story. There's no narration that's really needed because you get the people involved in this kind of speak. It's like you seem like you're kind of a fly in a wall when you're watching this, because you're there listening to their conversations, their meetings, their discussion, and it's coming from them. No one needs to tell you, well, next thing happened. I like that you're basically in the room with them as a viewer, which was kind of cool.
And that's why I took myself out of it. I did cut some a version early that had me in it, but I decided that feeling of being immersed in the action of things unfolding in front of you was better if I wasn't a mediating presence. I wasn't saying, this is this person, and here's what they're working on, and here's what I think, and here's what's going to happen next, but rather to just take us into the flow of the river.
Mm-hmm. What is it like to be in a room during these discussions with these people who are super passionate? As you can tell, that's the number one thing that pops off at the screen is how passionate and dedicated they are. I'm almost wondering the whole time, like how many hours they spend working on. Is they sleep? Because it seems like such a immersive commitment to be in these rooms and go on this long journey in a sense of discovery. Do you get any rest during this? Like, what are the kind of day-to-day lives of these people who are working on this so diligently? Because it seems like it's literally their number one thing in life that they're committed to.
There's an old distinction by Isaiah Berlin between the fox and the hedgehog. And the fox knows a lot of things and zooms around among tasks, and the hedgehog knows one big thing really well. And this film, in a way, is about the hedgehog view of the world. Andy Strominger and Stephen Hawking and the team, the Event Horizon Telescope team, really had a goal. I mean, this was, for Shep Dolman, one of my colleagues and friends, who was then the director of the Event Horizon Telescope. He worked on this project for 20 years. And Andy Strominger, and Stephen Hawking for even longer on their side of the theoretical project. So I think that it was something that you really have to be passionate about to devote your life to it, to say, here's a really big goal, a really big mystery, and if we can crack some aspect of this problem, it's worth it. And I wanted to convey that. And there were times, when we were writing up those papers, we first got the image, as you'll see if your audience gets a chance to see the film, we got the first image, came up on the big screen in 2017, but we didn't release it until April 10th, 9:07 a.m. in 2019. And that intervening period was one of constantly, what if this is happening? What if this is an artifact? What if we're fooling ourselves? What if we've put our expectations in front of actual evidence? How do we do this? And we were up constantly working on that and challenging each other, night after night, writing this, rewriting those papers. There were 6 connected papers that all came out the same moment. We had the announcement was made all over the world in 6 different sites and 6 different languages, and no one was going to show this image before 9:07 a.m. on that day. And perhaps the most amazing thing is that 200 academics kept their mouths shut for a year.
Right. That's the most improbable thing of everything. Honestly, there's no way you could find like that many amount of people to really keep a secret that big for that long. That was absolutely unbelievable. Almost as big as finding the picture shot of the black hole.
People didn't even tell, their families. I mean, they didn't show the image to their family. I mean, it was really hard because we were so excited about this image.
I can only imagine. Another thing that stood out to me is that how many young people, I didn't know what to expect initially. I would think these are scientists who have been doing this for decades, kind of in their older phase of life, but how many young people were involved on this project in a sense, and part of these high concepts. That was kind of, in a sense, really surprising to me, see how many young people are such an instrumental part of these sort of findings.
I think that that's absolutely true. We had even an undergraduate working on the
Wow.
project. We had a bunch of graduate students, postdocs, assistant professors, associate professors, full professors, eminence grise. I mean, we had everybody, and we had people working in Japan and China and Korea. We had people in all over Europe. We had people, in California and Arizona and all throughout the United States, all through the East Coast, and a big group in Boston. We had people stationed at telescopes at all, in Greenland and the South Pole and in Spain and Arizona. I mean, you had to have this international collaboration. You had to have young people who were excited about it, who had new ideas. You had to have people who had experience with these machines and with how to understand what was going on. It really was a collaboration, and I wanted that to come through in the film, that it took this, I mean, people say it takes a village. It took a planet.
Literally, and where all those kind of docking stations were stationed all over early on in the film, they're like all over the world, globe, south, in South Pole, I believe it was just Chile, United States, just literally all over the globe. Spain. It was interesting how it was like a world collaboration to make this happen, and
And the reason is, you can understand this if you think about building a telescope. If you want to be able to amplify that light and really be able to see things far away, even with an optical telescope, you want it to have a bigger and bigger mirror,
Sure.
and ideally you really needed a mirror, a radio mirror, so to speak, the size of the Earth. You can't have that. So what we did was to treat each of these telescopes as if they were interconnected parts of a single antenna. We made the Earth into a giant antenna, and with that, we were able to see this. I mean, the black hole is enormous. I mean, this one that we looked at is the size of the solar system, and
Unbelievable.
but it's so far away, 55 million light years away, that it would be like taking a telescope in New York and reading the date off of a quarter in California. It's an incredible amplification that you need to be. No one had ever made an instrument that was so able to see tiny details that deep into space.
That's what blew me away. I think there's a diagram. It shows kind of the Milky Way, and it's like, wow, that looks far, and that little blimp, and when you solar system, and then you go all the way off the grid to connect to this, like millions of, you can't even imagine sort of the amount of light years away that stuff is, and how far. I'm just wondering, how do you even create an instrument that can literally, like you said, that analogy you just gave was pretty spot on in the context of it. How do you even create something that can view something that far? It was just literally, that's the hardest thing to explain to me. It's just like, how do you create such a device that can actually capture something that impossibly far away?
Well, if you imagine, you have a telescope with a giant mirror,
Mhm.
but suppose you want to make it much bigger than the biggest mirror you could make. You could imagine taking little shards of a mirror, spreading them all out so that they're pieces of an even bigger mirror with big holes between them, and then capturing the light at each of these shards and bringing them all back together again and recomposing the image. That's what we did.
Hmm.
These telescopes scattered all over the Earth existed already, like the two huge complexes in Chile. And I mean, those are $1 billion,
No question. They
giant
look like they
things.
would be.
But though we didn't build those, we simply connected those. And that connection, by bringing the data together to a supercomputer, we were able to reconstruct this image.
Wow. That's absolutely unbelievable. For me to think about like a year and change of a span, I mean, well, technically probably 2 years until the release of the image. That's a short amount of time to put all that together to get that image. I felt like it feels long when you're watching it, like the years, but technically in a grand scheme of it, it's not that long of a time frame to get this actually done.
The scale of this really does make you recalibrate our thoughts. The photons that are in that orange ring that we produced in the image left there not that long after the last dinosaur died. And it took 55 million years for those photons to get to us. And then they had to get through our atmosphere, which is the hardest part of their whole voyage. And by a great good stroke of luck, the five days in a row that we were observing in April of 2017 were perfect weather all over the planet. That's
in
really
itself
amazing.
Yeah, putting that's almost as improbable as 200 people not spilling a secret in itself too. You had some good luck along this journey, no question.
We did, but it was a long time in the making. And many of the people in the project were worked on it for years and years and years to have that moment. And so it was such a thrill when we finally got that image. And it's really just the start. I mean, now we can begin to think, if we could see more finely inside that ring, theory tells us we should see a series of fine, narrow rings converging to the inner part of that big blurry ring. That big blurry ring is actually the composition of many little rings within it. And if we could start to pry those apart by making more telescopes, by putting telescopes into outer space, in this ambitious future program that we're starting to craft, that we could learn all sorts of new things about the nature of black holes, how fast they're spinning, what their histories are, what happens when they collide, and so on.
Yeah, Peter, I made me think too, like, how far of a capability do we have? Is there a foreseeable, in a sense, future of how much information we can get on black holes? Can we actually find out what they specifically do? Is there a probability of that I don't know, in our grandchildren's lifetimes or any sense like that we could get to a point where we like have that understanding what actually happens? Because I came into this movie, the knowing about black holes, I always thought black holes I associated with, oh, you go in a black hole and you're like transported a different time. I think movies do that. Like you transport to a different, 100 years back or 100 years to the future. I associated black holes with, and technically, when someone appears there, then you disappear and appear in a different time frame. That sort of was my, I guess, idea correlation of black holes.
Well, there's a lot to understand about black holes. And we're really, even though it's been 100 years since Einstein and his friend, the astronomer, polymath astronomer Schwarzschild first figured out the equations that govern black holes and that showed that there might be something like a horizon. That was, 1916. And here we were 100 years later, almost exactly, when we first began to see this image. That's the amount of time that it took the whole scientific community to be able to understand this. And I think as we go deeper into this, we'll learn more. We'll be able to measure how fast they're spinning. We'll be able to look at a second black hole and in the fairly near future, the one that's at the center of the Milky Way, called Sagittarius A star. As we extend the network, we'll be able to look deeper into space and see other black holes, maybe 10,000, 20,000 of them. By looking at the whole population of large numbers of black holes, we'll learn about how they evolved and what their dynamics are. So there's much still to be learned. And along the lines of what you were saying, there are possibilities in space-time of having things like wormholes and being able to figure out, do such exotic objects actually get realized? So I think there's a lot still to understand. And the things that seemed pure science fiction, even Einstein didn't believe that black holes were actually real out there. Now we see they're not only real, but they play a huge role in the formation of galaxies and the voids in space where we don't see stars. They shoot out these jets that cover not only the size of galaxies, but clusters of galaxies. In
Mhm.
some ways, these are the biggest objects in the universe. So there's much to be understood. What launches those jets? What holds them together? Uh, do they move around? These are like giant lighthouses that go all the way out to the edge of the visible universe, and we're starting to understand them. And this work, the Event Horizon Telescope and related projects, the Great LIGO project that looks at gravity waves. This is an era of black holes, and we're going to learn a lot about them in the next
Seems like this is
generations.
a great start. Wanted to kind of end off asking you about Stephen. I mean, he's such a prominent figure in this community and just worldwide. And it's interesting because you see also, obviously, the unfortunate passing of him along this journey of what you guys were working on. Um, I'm sure it was surprise to everyone, losing Stephen kind of abruptly, but how much how much contribution did he aid in this process in a sense? Because it seems like he was really at the center of it. And um, did he necessarily leave a knowledge with you guys that you can still use going forward without him? Is there a sort of things that he imposed, sort of wisdom or future things he was potentially working on that you guys were able to gather now that sadly he's not a resource for us, for future discoveries?
Stephen Hawking was really central to this, and over the course of the last 5 years, getting to know him was one of the great pleasures of working in this area for me and making this film. He was an inspiration, not only by who he was, but by his ideas for this project, the theoretical side. And I think everybody, whether they were theorists or observers, really wished they could have shown the final
Mm,
result to him, the picture of the black hole, but also the theoretical result that looks like a first important step towards resolving a paradox that he unleashed on the world back in 1974. And he was trying to solve. So you see in the film, and I really wanted this to come through, Stephen Hawking at work, not just Stephen Hawking, the oracle, not just Stephen Hawking, the popularizer, which he did that in an amazing way, not only as somebody who is an inspiration by working through disability to enormously transformative results in science, but also just Stephen Hawking working on a problem of the utmost importance. And his colleagues, uh, Andy, Malcolm, Sasha, often came back, and you see this in the film after his death, and wondering, what would Stephen say about this?
mm.
How would he think our next step should go? And I wanted that to come through. The Stephen Hawking, not only as an inspiring figure to the general public, but also as somebody who cared about his colleagues and friends that were working with him, and they cared deeply, profoundly about him, and not just the loss of Stephen Hawking that you saw in giant parades in London and in Cambridge, but also what it meant to the people who had known and worked with him for years and years.
Right, the
So
person.
the person and the
Mm.
thinker, and he loved being part of this collaboration. He loved this work, and he loved the world around him. And he was visited once in 2016 here in Cambridge, Massachusetts, and we had a dinner party. He had a great time. He wanted to meet, to talk to people, meet people. I mean, he was a person beneath the kind of iconic status that we've given to him, and I wanted to see that. We never had that with Einstein. There's no
Right.
film of him working. I wanted to see Hawking uh, engaged, and I think that that's one of the things I hope people will come away from the film understanding.
No question. I think you documented that, and as well as everyone else part of it working. You see people at work legitimately on this, and I think it was a really cool way that you brought it to life with putting the viewer in that room, throughout the journey. And I thought that was a lot to take away and learn just by the process of how this is done on a daily basis. So fantastic work, really phenomenal stuff. I think it gave me a lot of clarity too to kind of a mystery, just like, having kind of a basic concept and knowledge of it. I think it gave me some more advanced, it shed a more advanced light on what I knew about it. And I think it continued my fascination even more now going forward with it. So appreciate you doing that.
Oh, thank you. And Jim, I really appreciate it. I appreciate your interest. Black holes are objects that are inspiring to us. They make us think beyond the normal. They're not like the objects that we encounter in everyday life or even in everyday astronomy. There's something so elusive and suggestive about them. They remind us of, as the title of the film suggests, of the edge of what we know, and how exciting to be able to get in and think about that at this moment, which is really an epoch where black holes have come to the center of scientific thought.
No question. You guys accomplished a heck of a feat, but in many regards, but also kind of opening up eyes now with the film, on another scale too, for people to find interest in it too. And the more people that find more interest, the better it is for everyone at the end of the day. So
I hope so.
thank you so much, Peter. Really appreciate your time and work, and thank you for talking to me and shedding more knowledge onto me.
A pleasure, Jim. Thanks for having me on your show.
Take care. Bye-bye.
Black holes are the most mysterious objects. You look up in the night sky, and of course, you don't see them, but you know they're up there, almost mocking us. Try and figure me out.